we are back. Alright, today we are going to quickly talk about the scientific method, which you should already be familiar with from biology. So in general, science, biology, chemistry, and as you progress into physics, it's a plan of action, or it's a procedure for processing and understanding information. So when you think about science, when we're doing an experiment, for every experiment that we do, there's some sort of procedure. And normally what you do at first, you perform the experiment. So first you have the experiment. And the reason why we want to perform the experiment is we want to test some sort of hypothesis. Okay, we want to answer some sort of question. Then, once we do said experiment, we're gathering new information to determine if that hypothesis is valid. Okay. And even if we think a theory is correct, we always want to challenge our current beliefs. Okay, so we can, if a belief is true, we can always conduct that experiment. Okay, so first, we conduct the experiment to test the hypothesis. And what we already did yesterday was we made observations. And remember, those observations can either be qualitative, those involving the 5 senses, or those that are quantitative, those that involves some sort of number, as well as a unit. So we make those observations, we see if it agrees with our hypothesis or not, and then if it does not agree with our previously held belief, we have to try again. And we keep on doing that until we come up with some sort of theory. And when we're doing these experiments, it might not always progress smoothly and efficiently. A lot of times, as people and as scientists, we tend to see what we expect to see, and sometimes we don't notice the things that we don't expect. So one thing I want to stress this year in lab is to not do that. It's okay if you do not get perfect data. There's usually some sort of reason for that. Okay. I do not want you to misinterpret any data or make any data up. It's just do the experiment again, changing one variable, and see what that changes. So then once we develop a theory, then we can develop more predictions, do more experiments, and modify our theory. Then if we do a theory enough times, we come up with a law or scientific law. An example of a law that we encountered during our first experiment was the law of conservation of mass. The fact that mass is neither created nor destroyed. Okay? Even though the mass of the candle went down during the course of the experiment, that mass did not just disappear, it was just converted to gaseous carbon dioxide. And one other thing, when we are talking about a hypothesis or hypotheses, we are coming up with a possible explanation for an observation, which we're doing in each of our labs. Then, once we conduct said experiment, we come up with a theory or model. We're trying to explain why something happened. It's a certain type of interpretation. It's why nature behaves in a particular way. And normally, in chemistry, remember we're talking about the microscopic world rather than the macroscopic world. And we make and test those hypotheses by making those observations, something witnessed and recorded, and something that you put into your lab notebook. Always when you're making observations in lab, you have to make sure that you record them, so if someone else is doing the experiment in the future, they can replicate or repeat your experiment and are able to get the same results. Alright, that's it for today. See you next time.